So for today, we're focusing on exponentials and logs, and this is the graph of an exponential. Now, some of you guys didn't have this tail end part, and that might mean that you forgot that there's an asymptote in there. Did you forget that there's an asymptote in there? I bet a lot of you did. All right, so if that's y equals 2 to the x, I want you to think about why there's an asymptote there. Is there any way I can put this to a power that will make my 2 turn negative? No. Could I make my 2 get smaller by putting it to a power? Yeah. Yes. Could I make my 2 turn negative by putting it to a power? No. That's why there's an asymptote there. It'll never cross into the negatives. No matter what you put in, you can't make the 2 turn negative. All right. Now, is there another kind of graph that has asymptotes? Yeah, and it's definitely different. It's log. We're going to be talking about logs again in a minute, but I just want to remind you, take a second. The research shows that you will remember this better if I make you try to remember it. What does the log graph look like? Hint, there's an asymptote also, but it's different. Hint, the asymptote goes the other way. And I gave this lame example. What is a log, really? It's a tree that's been blown over in the wind. See how that sort of looks like a tree that's been blown over? That's what the log graph looks like. And the asymptote goes here. All right. Remember, this is not your whole lesson on logs. It's like you'd totally be taught a lot more than this when we taught you the graph of log, but I'm just trying to give you the brief reminders of these things. So if that's log base 2 of x, what if I did a plus 1 here? Now where would everything move? Up 1. Good. What if I put it in a parenthesis? Hint, it's different. Now it's part of the argument, and it's going to move left 1. Very good. If that wasn't something you remembered, maybe you should go like this and then label it to yourself. That's left 1. This would be up 8. Okay. So, exponentials. Let's see if you still remember what exponentials are about. You don't have 2 llamas this time. This time you got 48 llamas, and you're taking really good care of them. So they're growing at a rate of 85% per year. Can you write the equation for that? What was the start value again? 40. 40 llamas growing at what percent? Was it 80% or 85%? I think I said 85. 40 llamas, 85%. All right. If you didn't have a y equals, you didn't have an equation. And then it was 40, and then you got this 85% thing. How do you do that? 1 plus 0.85 is the best way to do it, because then it's kind of like those loan problems where you'd like divide by 12, except we're not doing this monthly. So, okay. And then I put it to the x, because if you have an x in the exponent, you're good. Now, I said it would happen over 1 year. If you really want to, you could put divided by 1, but that's just going to make it look messy. But if I had said it happens every 6 months, you'd probably need to include that somewhere, right? So you'd go like divided by 6. Okay. Or you could change the problem into years instead of having it be in months. All right. Do you feel like you understand how to set up an equation like that? Good. What if I did this? Y equals 60, but then it does 0.85 to the x. Something feels different about that. Is it still exponential?
Yeah.
Yes. But it's exponential what? Decay by what percent? 15. And what's the, oh, wait a minute. There's a name for this. You know, I don't want to confuse this with the other ones that are called recursive, so I'm not going to go there. I'm just going to stop. The other ones, you remember how they had a common ratio and then the rate was different? Well, for this kind, we'd just say the rate would be 15% decay. Okay? All right. Okay. So what else do you have to know? Well, do you remember weird exponents? That kind of is in the exponents unit. What happens if you have x to the negative third? What does that do again? It's kind of like x to the third, but what? So let's see if you remember what a negative exponent does by giving you a number to it. Let's say I said 27 to the negative third. Don't say the answer. Write the answer. And I understand you don't know what 27 to the third is. It's a huge number. Seeing a lot of blank stares. I think you forgot. Negative power puts 1 over your answer. Okay. Now that I've reminded you of that, this should be easy to do in your head. Don't say it. Write it. 9 to the negative second. What's that? If these confuse you, just start with taking off the negative and saying, well, it's just basically 9 to the second, which is 81. But then 1 over that. 1 over 81, raise your hand if you had that one right. Okay, awesome. Then do you know what to do if I make it 9 to the negative 1/2? Don't say it. Write it. What's the 1/2 mean? Square root. And then the negative means 1 over it. So then if the square root of 9 is really 3 and then you put 1 over it, it'd be 1/3. Raise your hand if you had 1/3. Okay, awesome. Then why do you need those? Because you have problems like this. Log base 3 of 9 to the negative 1/2. And you might be like, I don't remember how to do that at all. And I don't blame you. But I'll remind you. Would you agree that this 9 could be replaced with a 3 squared? Does that ring a bell? And now the bases are the same. And that was a big deal in logs. If the bases are the same, I always said it this way. If the bases are the same, the answer's already there. It's these two. And do you know what to do with them? Multiply them. So final answer, what's 2 times negative 1/2? Negative 1. So the answer to this is negative 1. It's not log of anything. It's just negative 1. That's it. Now you might be like, well, if I had a calculator on this test, which you will, I'd just be able to type that into the calculator. It's true, but there'll be times when we'd throw a variable in there, and that means you couldn't. Like this. Log base 3 of x plus log base 3 of 7. Good luck you getting your calculator to do that for you. Take a second, see if you remember that kind. Act like the test is today, and that's one of the finals questions. How do you combine those together? That's log, they're both base 3. Sorry, I was writing a little fast. And therefore messy. Log base 3 of 7x. Raise your hand if you had that one right. Awesome. What if it had been minus, though? It's just a simple little change. And it's not 7x anymore. What is it now? X over 7. Very good. Okay. Now let's say that that equaled 2. I can just bring my equals 2 down. Would you know how to take it from here then? It's the most important thing you got to know about logs. Is how to rewrite them so they aren't logs. Get it? So it's not a log anymore. Do you remember the circle of logs? It's like the Disney movie. Some musician just rolled over in his grave. That to the that equals that. 3 squared is 9 equals x over 7. And that's easy to solve. Times by 7, 9 times 7, 63. Raise your hand if you had 63. Awesome. All right, that circle of logs thing is a big deal. Got to know that left and right, upside down, sideways. Because it can also go backwards. X to the 5 is equal to 11, even can be solved if you know the circle of logs. Well, I wouldn't even need logs for this one. It's when there's an x in the exponent. Let's do this one, but without logs. How do you solve this? I got to get x alone. What do I do? Remember? You are correct. And that's just a 1 now, so it's x to the 1, which is just x. Yay, that's done. No logs needed. All right, but what if it's the other way around? 5 to the x equals, let's say, well, if it was 25, it'd be way too easy. So how about if it's 26? Use a log to solve this one. This one doesn't have a log, and you've got to make it be a log. Log. To start with, just write a log. And then you'll realize, oh, there's got to be a couple numbers next. And then you're like, oh, there's some sub number down here. It's like the base. And then which one feels like the base? Oh, the 5 feels like the base. Log base 5. And then do you remember the circle of logs? You go over here next. And then you come back here. There you go. Log base 5 of 26. All right, there's a couple other little logs you need to know. Log base 3 of 11. You don't have to know that one. How about of 1? Remember that one? You're right, it's 0. I gave you a dumb little saying, there's a 1 in the argument. You won the argument. What do you get for winning the argument? Nothing. 0. It's very true. You can be arguing with your parents over something, and they're the one you like just decide if you get the car keys tonight. You might win the argument, and you might get worse than nothing. They might be like, yeah, I'm not giving you the car. All right, yes?
Can you do the logs to the log?
I'll show you the log to the log in just a sec. Give me just a sec. All right. So this is one of those little patterns. Is if there's a 1 in the argument, you're supposed to know what that is. What if it was like log base 3 of 1/3? Well, these only work if the bases are the same. So then you better make the base the same. How can you make that into a 3? 3 to the what? -1. Now what's the answer to it? -1. All right. Then there's this other kind where the log is up in the power. And it's actually incredibly easy if you know what's going on. It's just 11. Why is it just 11? Well, because the bases are the same and the answer's already there. And I showed you the long way of doing this. This right now is not technically a log. It's a 5 to a power of a log. So you make it a log, and then you ask yourself, okay, if I was going to make this into a log, how do I do that? I would make this equal to x, and then I would go log, what's the base here? Oh, the base is 5, and then you do the circle of logs. Log base 5 of 11, and that hopefully shows you that x has to be 11. That's the proof that the answer is 11. You don't have to do that. It's just how you can show that if these two are the same, the answer's there. Okay, is there any other kind of log? Oh, there's a million kinds of problems. Here's one more. log base 3 of x plus 1. We like this kind of problem because it makes you do factoring and solving. Plus log base 3 of x is equal to log base 3 of 0. I wonder if you're going to know what to do with this. Somebody say it as soon as you notice it.
Quadratic.
Nope, it's not because of the quadratic. Undefined. Why?
Because log base 3 of 0 is impossible.
Yes, you can't have a 0 there. The base and the argument can't be 0 and they can't be negative. All right, cool. But don't just erase the whole problem. We'll change it so it's some other number. Let's put a 1 there. You have a 1 there? Yeah, and you won the argument, and so now it equals something. And see if you can finish this one. I gave you this rule in logs. I said if you can combine them, you should. So you get them together into one log base 3. And then I put the x in the front just so it looks cleaner. Like that equals log base 3 of 1. And now I get, some of you are going to be like, but that equals 0. Should we make it a 0? You can make it a 0 if you want to. Or you can use a different property and go, there's logs on both sides. If the bases are the same on those logs, you can just take those logs out. Now, you want to do it that way? You can. Or you can do it the other way, where this equals 0. Well, then if I did that way, then what? Well, then you'd go 3 to the 0, which equals what? 1, and you get the 1 back again. Equals all that. So x times x plus 1 is equal to 0. Nope, it equals 1, because 3 to the 0 was 1. You can put the 1 on this side if you want. Either way. And then you might have thought, oh, the answers are just going to be 0 and negative 1. No, they're not. If this whole thing equaled 0, it would be. But I showed you two different ways. It equals 1, actually. So then, what do? You multiply it out. Now I'll have x squared plus x equals 1. And with every quadratic, if you're solving a quadratic, you want to set it equal to 0. So I'm going to take away 1 on both sides. Now it equals 0. And now if you can factor it, you should. But I can't factor it. You could try for a while and you realize that won't factor. Do you know the follow-up to if you can factor it, you should? Quadratic formula, very good. X equals negative b, which is negative 1, plus or minus square root of b squared, which is 1, minus 4ac, 4 times a times c. That's where most of the mistakes are made, is right there. So I'm going to be careful. B squared minus 4a is 1, and c is negative 1. And there's two negatives, c, so it's actually going to be plus, and that'll be the square root of 5, all over 2a, which is 2. So it's negative 1 plus and minus the square root of 1 plus 4, which is 5, all over 2. Cool. You got to know that that's an actually okay answer in this class. Is that imaginary? Just because it's weird looking doesn't mean it's imaginary. What would have had to have been there to be imaginary? A negative under the root. If it was square root of negative 5, now that would be imaginary. All right, cool. All right, now I'm going to take a minute and look at your review sheet, the pages that I think you should do. We started with this. If I had to do this, I would start with combining everything I could up here. And that would become 3 times the 4 makes 12. X to the, and do you remember that on this kind you add the powers? It's true. What 7 and negative 3 makes? 4. So that's going to be 12x to the fourth. And then I go do the bottom. And then once I was done with all of that, I would see if anything would cancel on the top and the bottom. But all right, how about solving this? Can you get this into just 1a? A to the power of something? Because then it would be a to the power of something, and this one's a to the eighth. And then remember the deal if the bases are the same? Then the answers are up in the exponents. This must be a to the 5. What do you think? You subtract the bottom, so you could say subtract negative x. So you're right. It ends up being 5 plus x. Because these powers are subtracted. So it'd be 5 minus negative x. And once the bases are the same, then this just equals this, and then you can solve a new little equation there. All right. How about this? Do you remember the kind where you get the bases the same? Wouldn't it be awesome if both of these had a base of 3? You could do that, couldn't you? This could be 3 squared, and this could be 3 to the third. And then they still have their powers. All right. Is this exponential growth or decay? Oh, that's too easy. All right, on to the next page. This one's got some more exponential stuff, and it's just going to be testing, like, do you know which of these it is? Because, like, that's telling me a y-intercept of 6. That doesn't have a y-intercept, a.k.a. it has a y-intercept of 0. That has a y-intercept of 5. And only one of these has a really big base, and that's that one. So from those, you should probably be able to tell which of these it is. On to this one. We did a little bit of this yesterday. 11% growth on the condo. Ooh, growth by 11 can't be that one. That'd be decay. And it's not that one. I would actually make it shrink too. 11 in front now, that's not it. Must be that one. All right. So I think you can see there's a lot of logs in here. If you go on to the next page, more logs. This, remember the base of this is 2 to the x. Remember that looks like this. But one more thing about graphing, and I know I've kind of burned you to the last of your brain power, but go to problem 29, make an XY chart. I don't think anybody in here is going to get it right unless they make an XY chart and find some points. You could seriously train a 6th grader to do this problem easy. You just tell them, find points that work. Stick in any number you want for x, see what you get. If I stick in a 1, and if I get enough dots, it's going to be right on this curve, and I'll know, oh, there it is. Join the dots. If I put in x is 1, I would get 4 times 2, which is 8, plus 2 is 10. 1 comma 10, that's a point. Find more points. Don't forget that negative 1 is a powerful 1. It's not like incredibly hard. 2 to the negative 1 means you flip it over and makes it 1/2. And then 1/2 times the 4 would be 2, and then you add another 2, and you're back to 4. So when you put in negative 1, you get 4. Okay, so make points on an XY chart to graph stuff. That'll work for this one too. You get XY charts are powerful for graphing. You can graph almost anything if you just stick the numbers into an XY chart. And there. With that advice, we can get you all there. So that's where we're going to stop for today. And you should be able to finish your review sheet up through problem 30. And I know that was a lot, but we only have 3 days left. Tuesday, Wednesday, Thursday. And then on Friday, you won't have this class. You'll be taking your hour 1 and 2 finals. So, all right. That's all I got for you for today. Way through number